Hello friends, this is the second video of capacitance. Here we will discuss parallel plate capacitor with or without dielectrics. Okay, now first you consider parallel plate capacitor with single dielectric. Now this is two identical parallel plates. Okay. Now having charge densities are plus sigma and minus sigma. This is the charged plate and this is electric plate. This is the distance between the parallel plates. Within the plate region, electric field is uniform. Now, if E is the electric field at any point within the plate region, then you can write E equal to sigma divided by epsilon over sigma divided by epsilon, that equal to sigma divided by epsilon naught into epsilon r, or in general epsilon naught into, you put epsilon r as k, dielectric constant. Okay. Now each sigma divided by epsilon 0 k, and this value you take, this is a constant within the plate region. If you charge this plate with a charge sigma or surface charge density sigma, then what is V? V is minus integration E dr. If you use this formula, then after solving you get V equal to sigma by epsilon into D. This is the value. Sigma by epsilon D means same. That is sigma divided by epsilon naught k. This is E into D. This is E. Okay, ED. Integration is uniform. Take out E. Outside the integration sign, you put D to 0. Okay, I am taking D to 0 limits. This is. So this equal to, you write then V equal to, or sigma means Q divided by epsilon 0 K A into D. Okay. Now what is the capacitance of the capacitor? Charge given divided by potential. Charge divided by this total potential Q cancels. This is epsilon naught K A divided by D. This is the value. C is epsilon naught K A divided by D. Now this formula indicates that if the entire medium is filled with homogeneous dielectric having constant K, then capacity of that parallel plate capacitor varies directly with dielectric constant, directly with the area of each plate, and inversely with distance between the plates. Okay. Now if the medium is air or vacuum, then you put K tends to 1, the value of K equal to 1. Therefore C, air, that is written as a epsilon 0 A by D. So I am writing this formula as C M epsilon 0 K A divided by D. So from this you write C M divided by C, that is the definition of dielectric constant. Okay, definition of dielectric constant. If the medium is completely filled with the air or vacuum, you put this value. If medium is completely filled with some homogeneous medium, Therefore, in general, you take this as a, I am writing single dielectric, completely filled with one dielectric. Okay? Again, another term is if A is circular plates, you take A equal to pi r square. If it is a rectangular plate, you take A equal to length into breadth. If it is a square, you take A equal to, that is a side square. Okay? Accordingly, you can solve the various problems. Okay? Now, this is the first property with single dielectric. Now, the second property is induced field and charge. Suppose this is filled with dielectric. Now, your external field is E naught, and within the dielectric, internal field is EI. So this opposes, EI opposes EO. Therefore, net field means resultant field, E equal to right EO minus EI. What is EI? EI is induced field. Okay? This is equal to EO divided by A, because we know that K is defined as a electric field in air divided by electric field in medium. This electric field in medium is E naught. Okay, electric field in the presence of medium is E naught. So therefore, you take E naught minus EI, that equal to E naught by K. Now, from this equation, you find out induced field. That is E naught minus E naught by K. This is E naught into 1 minus 1 by K, EI. So this is the value. Induced field. If the field induced within the dielectric, that means if this dielectric is like this, in the positive side, negative charge induces negative side, positive charge induces. This is EI and external field is E naught. Now, EI is equal to E naught into 1 minus 1 by K. Okay, therefore it is 1 minus something. 1 minus something means it shows that induced field is always less than E naught. EI is always less than E naught. Now, accordingly, what is charge induced? If charge induced is QI, QI is equal to charge given, that is Q naught, into 1 minus 1 by K. So this is the value, induced charge and charge applied or given. Okay? Now, third property is just to consider two dielectrics. In some books, it is written as a partially filled. That means, if this is a dielectric medium of thickness T, dielectric means its value K is greater than 1. Okay? If the first medium is air or vacuum, it is called partially filled. But air or vacuum is also taken as dielectric, having constant K1 is 1. So if you take, this is one dielectric, this is another dielectric, then you can take this as a two dielectrics. And after that, we will put for one dielectric. Now, if E1 and E2 are electric fields means resultant fields within the dielectrics, then what is V? Potential difference across the ends of the plates. Is, that is V is E1 into D minus T plus E2 into T. E2 is the field with dielectric having thickness T. E1 is the field with having another dielectrics having thickness D minus T, because D is the distance between the parallel plates. Now, if you remove the plates, remove this plate, move towards left or towards right, its thickness remains the same. Therefore, the thickness of rest medium is again D minus 2. That means if you touch this plate to left side or right side or place anywhere, nothing is going to change. Now, E1 is formula sigma by, that is K epsilon naught, I am writing K1, and E2 is sigma divided by K epsilon naught, I am writing K2. So now, further, the value of sigma, you take out common and epsilon 0 common, sigma is Q divided by A epsilon 0 into, you write D minus T by K1 one term by T by K2 is another term. That means if you charge the plates with a charge Q, or sigma is the surface charge density, then what is the potential developed across the parallel plates is, this is the value. Okay? Then what is capacitance? General principle, charge given divided by potential developed. Charge given by potential developed, therefore you put charge Q divided by, instead of V, you put this value, but here there is a Q. Here there is a Q. Therefore this Q and this Q, it get cancelled. Therefore this term comes to upward. This is epsilon 0. This comes to the numerator. Divided by, this term comes to the denominator. You put D by K1 one term, T by K1 another term, and T by K2 another term. I am arranging epsilon 0A D by K1 minus T into 1 by K1 minus 1 by K2. So this is your value. Okay. Now generally in our 11th and 12th class books, in NCERT or some other books, first medium is they are taking as air or vacuum. That's why they called this the partial effect. Therefore, if you take that property into account, that means if I am writing first medium is air or vacuum, then you put K1 equal to 1. In that case, you put K2 equal to letter K, because there is no K1. Therefore, you put K. Therefore, capacitance now becomes epsilon 0A divided by epsilon 0A divided by D minus T into 1 minus 1 by K. So, this is your value. C equal to epsilon 0A D minus T into 1 minus 1 by K. So, if you take two dielectrics separately, then this is your formula. This is. But if one medium is air, then you put K1 equal to 1. So, this is your another formula. Okay? Now, from taking that formula, let us start some properties, analytical properties. Okay. First property is presence of dielectric. Presence of dielectric reduces the air gap. This portion is minus mark. This portion is minus. Reduces the air gap. So this increases. This shows that capacitance increases. This is the first point. What is the reduced value? This is T into 1 minus 1 by K. It reduces the equivalent air gap. Equivalent air gap is this is. Therefore, it is d minus something means denominator C is inversely proportional to. Therefore, capacitance in that case increases. Okay. In the second case, another property. If you take, suppose, number of dielectrics like this: K1, K2, K3, K4, K5, K6, thicknesses are T1, T2, T3. Then in that case, I am writing if T1, T2, T3 are number of dielectric thickness having dielectrics K1, K2, K3, then in that case, C is epsilon 0A divided by D minus of T1 plus T2 dot dot plus T1 by K1 plus T2 by K2 like this. This is written as a epsilon 0A D minus sum over T plus sum over T by K. This is the value. Epsilon 0A divided by D minus sigma T and sigma T by K. Now, if you consider all these dielectrics, there are different values, but thicknesses are equal. I am writing here another property. If T1 equal to T2 equal to let T, then C equal to write epsilon 0A divided by D minus sigma T, that is T1, T2 let T, and the entire dielectric is completely filled. I am writing here. Gap is filled. If gap is filled, then D equal to sigma T. So therefore you write epsilon 0A divided by sum over T by K, sigma T by K. This is another formula. Another thing is, if you assume another property, if you assume the first medium is air, that means K1 equal to 1, but K2 equal to, or K2 it tends to infinity, that means very large. How it is possible? If the medium is metallic instead of dielectric. Instead of dielectric, if the medium is a conductor, good conductor, then in that case K2 is very large. If K2 is a very large, then you put, that is C from this formula. C is epsilon 0A divided by D minus T plus T by infinity, that is epsilon 0A divided by D minus T. This also shows that presence of a metallic conductor increases the capacitance. Okay. Now these are all about a parallel plate capacitor, but practically somebody may feel doubt: is it practically used, a parallel plate capacitor? Is it practically used? Let us try it. That means in air or vacuum, this is epsilon 0A divided by D in single medium. If you take C equal to 1 farad and D equal to 1 centimeter, then find out the value of A. Okay. Now what is A? A is, the value of A is the value of A is C D divided by epsilon naught. This is CD into 4 pi. I am writing multiplied with 4 pi by 4 pi epsilon naught. 1 by 4 pi epsilon naught is 1 by 9 into 10 to the power 9. Capacitance is 1. This is 1 cm means 10 to the power minus 2. Again there is a 4 pi. So if you multiply this represents your something meter square. Mark, the order is very large. So this shows that large plates are required. Large plates are required to produce such capacitance, but practically this is not used in electrical and electronic devices. But theoretically it is possible. Okay? Now, If you like this video, like it, subscribe and share it. Thank you.